Okay, so this screencast accompanies this Ealing Film Loop retrograde motion, the geocentric model of the universe. I show this film loop during lecture. This is meant as an accompaniment to that. Okay, let me go ahead and now set this into motion. I do, of course, have the raw recording of this film loop posted for you, if you wish, on YouTube in the playlist called Ealing Film Loops. Okay, so getting past the credits here. Okay, what we have here stationary is a light bulb to represent the Earth, and then moving on two circles at the same time, we then have the planet Mars. And now the two types of circular motion then combine to trace out the following figure, much like I draw on the board during lecture, like so. Okay, once again, what you are in fact seeing here is two types of circular motion combined together, and they built a machine for that purpose here within this film loop. They're going to go ahead and turn the lights on here in just a moment, like so. And then here's the machine that they have built. So once again, the Earth is at the center, and then that large arm is representing the deferent, and then the small arm is representing the epicycle. Okay, now what does it all look like from Earth as this occurs? Well, they're going to show us that here, and these two gentlemen are going to help us out. So I like to refer to these guys as two of the ex-presidents of the United States. We have John F. Kennedy on the right and Dwight Eisenhower on the left. Okay, so what these two ex-presidents here are going to do is they're going to place a camera at the position of the Earth that's at the center of the machine, and this will then depict what retrograde motion looks like as seen from the Earth. Okay, so Dwight Eisenhower's job is to unscrew the light bulb while JFK waits patiently with the camera, like so. This immediately answers the question, how many ex-presidents does it take to unscrew a light bulb? Apparently the answer is 2. Okay, now John F. Kennedy's job is also to focus the camera. He's doing so carefully as we can see here. So is it focused? I don't know. I guess so. All right, he agrees, and now they go and they sit down. Okay, and then what these guys are going to do is they're going to turn their machine on. They're going to show us what the view looks like as seen from the Earth. Now, the whole time that the rotation occurs, notice that the camera is always pointed in the same direction. The camera does not rotate. And now, retrograde motion as seen from the Earth looks like this. Whee! Like so, as the planet Mars goes by. Okay, now, all kidding aside here, what we actually don't see with the naked eye during retrograde motion is we do not see the planet get larger in the sky, brighter in the sky, but it does not get larger. You have to remember that to the ancients, basically the planets were not necessarily thought of as places. They were just points of light that behaved rather erratically as they moved in the sky. So to simulate that, in other words, just representing the planet here as a point of light, they're using, in this case now, successively smaller and smaller light bulbs. When viewed through a telescope during retrograde motion, yes, the planet Mars does get larger in the field of view, but this was all well before the inventions of the first telescopes in the 17th century. Okay, so now using, once again, successively smaller and smaller light bulbs, here's basically more or less what retrograde motion looks like to the naked eye here. Once again, it's just a point of light in the sky behaving rather erratically. Let me go ahead and let this film loop then finish. Once again, the raw recording of the film loop itself is also posted for you here on YouTube. Okay, like so.